I'd been trying to get to Orkney for 2 years, and so when I finally got on the ferry from Aberdeen, it was a great relief. It was also a bit of a relief that the sea was so calm, as this crossing can be upsettingly rough and stormy. A quick geography lesson. Orkney is a cluster of islands just off the north coast of Scotland. It's notoriously windy, which may give a clue as to why I wanted to visit. We set off on a tour of the island in a Nissan Leaf with Jonathan Porterfield, who had kindly organised the trip.
That sort of fed Orkney. But as the renewables grew, they became more and more self-sufficient for electricity.
Right.
So it's got to the point now where last year, 2014, 104% of electric was produced on Orkney. So basically, they made more electricity than they can actually use.
Right.
So there's an excess that needs soaking up for the foreseeable future, and that's where EVs come in.
Right.
Because they could provide a real outlet for wasted energy. Right?
Yes, yeah.
It's clean.
Yeah. So can you quickly tell me where we are on the island and what we're seeing here?
Yep, this is the Hammershill Wind Farm.
Hammershill, right.
Yep, and Evie on the west side of Orkney,
Right.
mainland of Orkney. So we've got 5 Enercon E44 turbines here, 4.5 megawatts in total.
Right. When you're standing right underneath them, they do seem very enormous, but they're not the biggest ones they make.
No, not at all. These are actually medium-sized turbines.
Right.
So the tower height is 45 metres,
Right.
and it's 65 metres to the blade
To the
tip.
top of the blade when the blade's up.
Yep.
Right. But then quickly, because you started telling me about the foundations, because that's a lot. You know, often a lot of the criticism is, there's so much carbon used to make wind turbines. They'd have to be running for 50 years to pay back that
Yes,
stuff, which I know isn't true. But can you sort of give us a brief rundown of what you had to do to install?
Yeah, well, to give you an idea, the foundation for this turbine, most of it is covered over here, but basically there's 500 tonnes of concrete
Right, which
and
is
steel
quite a lot.
under this turbine.
Yeah.
So Enercon ran some calculations for us, and they had worked out that we actually paid back the carbon in terms of the construction of the wind turbine in the first 45 days of operation.
45 days, not 45 years.
But this is a very windy site. We're on top of a hill here, but we're only at about 150 metres.
Right.
So we're not that high.
Yeah.
But the elevation does help.
Yeah.
But generally, you've got the North Atlantic out here, you've got the North Sea here, very open. Yeah.
But I mean, are there ever days when they absolutely don't, where it's absolutely still and they don't turn? I mean, does that ever happen?
Occasionally, but
Oh, right,
but,
it does
yeah,
do
yeah.
that, right.
But then we get the days when the wind is so extreme that where the actual turbines can't generate because it's too windy.
Right.
So these turbines have they're called a Class 1A machine, so they're designed to operate in high wind speeds, and these machines will cut out at about 28 metres a second.
Right.
So you're talking there about just 65 miles an hour.
Right.
Which is
65 mile an hour,
fairly strong. But they'll cut in and out. So storm control will, it'll cut in for perhaps 5 seconds when a gust of wind comes through, and then it'll free itself up and start generating.
And what's the highest wind speed you've ever recorded at this?
127 miles an hour. One gust. Yep.
127.
Yeah,
That's
127
insane. Wow.
miles an hour.
Okay, just go in. Oh, brilliant. So here is the control panel, which is telling us what's going on up the top.
Not windy today, so
Right.
we've got 3.4 metres per second.
Right.
So we're only actually generating 20 kilowatts at the moment,
Right.
which is not a lot. Shows you this turbine has been operating for 31,500 hours,
Right.
and it has generated 14,862
Megawatt hours.
megawatt hours.
Goodness.
Of course, put 14,000 megawatt hours over 31,000, and that tells you your capacity factor.
But also, I think what's great about that when you see how many megawatt hours, I have solar panels which I've just passed 9,500 kilowatt hours in 3 years.
Yeah.
How many kilowatt hours in a megawatt?
1,000.
1,000.
Yep.
So it's done a bit more than my solar panels. Ooh. Now, Peter, I really wanted to meet you because you know there's a lot of people now that own Nissan Leafs. That's quite common, particularly in Orkney. But it was just the idea that you've got a wind turbine there and you've got solar panels. Which came first, the electric car or the energy system?
The first thing that came was the solar panels,
Right.
and a lot of people said, you know, solar
Yeah,
panels
in Orkney. It doesn't make sense.
And then we saw an advert for a company who were asking for people to lease them a piece of land
Right.
to let them put up a turbine, and we would get the electricity, but they would get the feed-in tariff.
Right.
And after that, we had wished that we almost converted the house to electric
Right.
heating and all the rest of it. And then Jonathan came up, and we went to see this car, and fell in love with it straight away.
Right.
And at that time, I was looking to change the car,
Right.
so that's why we went for it.
But in terms of your annual electricity bill, you've now got an electric car, you've got electric heating in the house, you use electricity. Is it an enormous electricity bill or is it quite small?
No, we're paying less than £14 a month direct debit, and we're
Right.
still in profit to the thing. So
Right.
probably 1,500 units a year.
Right, from the grid, from outside.
Well, that's what
yeah.
yeah.
Right. And what would you have done before you put all that in?
Well, we'd have been filling up the oil tank twice a year. We'd
Right.
have been paying £50+ a month to
Right.
the electricity company.
Yes.
Yeah.
Wow. So it's made a and you're buying petrol for a car as well. You would have been.
Well, I haven't put any petrol in that in 2
Have you?
years now.
Because that's the other thing is that on this island, fuel is generally more expensive than on the mainland.
Yeah.
So you've got that added incentive to go
Yeah.
to find an alternative.
Yeah.
Yeah.
And now we can go off somewhere without having to think, oh,
Right.
it's going to cost us
Yeah.
something. Because we just come back and plug it in.
Yes. Yeah. So I said we're in this brand new building with, I'm just going to say what I understand about it, but with underfloor heating
That's
throughout the
right,
building,
yeah.
which is heated by these mysterious white boxes here. So this is a you call it a heat pump? Is
It's
that
a
the
heat pump,
proper
yes.
term?
Yeah. These boxes basically work the same way as a domestic fridge. They take heat and compress it and put it out on the heating system. So in this case, we're taking it from the seawater.
Right.
Normally it's taken from the ground, but we've got pipes that go out to a manifold that are sitting just beside the pier,
Right.
and then from the manifold we go out to 12 collectors that are sitting in the seawater under the pier.
And that's just like plastic pipe.
Yeah,
that's
it's plastic
resting on the seabed. effectively.
Yeah, it is. It's just, I think it's 120 metre lengths of pipe coiled up and
Right.
tied to a pallet and then sunk in the water.
Right.
And that just
And that's
extracts
underneath the
water.
pier, so it's not really in anyone's way, I suppose.
No, it's
Yeah.
out the road
Right.
of the shipping, and
Yeah.
hopefully out the road of where anybody's going to drop anchors on
Yes,
it.
yes, I suppose that would be
Yeah.
bad, wouldn't it? But so what that does then, because it is confusing. So, you know, if we walk up to the edge of the sea, particularly, I think in Orkney, put your hand in the sea, it feels really cold, and yet you're getting heat out of that. which
Yeah,
is
we
confusing.
can always take more heat out of it because it's even once the water's frozen, you can still extract
Can you? You
heat
can-
from it. Yeah. So,
But what is the sort of what is the average temperature of the sea in the
well,
harbour
we're
here?
between 5 and 10 degrees over the year.
Right.
This takes the water in. It's taking the water in about 10 degrees, and it's generating 30-degree water out of that. They're set at 40 just now, and that water then goes to the underfloor heating circuits.
Right. And then so the only energy that's used then is for pumping the water. That's really the only input
Electricity
other
to
than
run the heat pumps,
Yeah.
and electricity to run the pumps that deliver the water from the
Right.
harbour,
Yeah.
and the pumps that deliver the water to round about the
Right.
building.
And so that, in terms of the energy use on the island, I mean, that's what's so fascinating about Orkney,
Yeah.
is that electricity, you know, in mainland UK would come from a variety of sources, including coal and gas and nuclear. But here, I mean, from what I
coming
understand,
from-
it's all renewable.
It's
isn't it?
all renewable,
Yeah.
yeah. We're exporting more than we're importing, so
Yeah.
we can claim it all as net
Right,
green
right.
energy.
So yeah, I mean, so in that sense, running the heating in this quite large public building, you've got a police station and a library and everything. Is
Yeah.
the impact is pretty
It should be
small.
none.
Yeah, it's amazing. So Lisa, can you explain to me, we're standing in this extraordinarily beautiful landscape and with this amazing facility down here, can you explain to me what that is?
This is the European Marine Energy Centre's wave test site at Billy-a-Crew. We have a similar test site for tidal energy up on the island of Udi as well.
Right.
We have subsea cables here that are dug in underneath the beach, lie on the seabed, and then our developers can come along and connect up to these cables. That then feeds electricity back into the substation that you can see behind us, which connects into the national grid.
They can basically plug and play. They can stick it out at sea and have a go.
So that is what we like to call ourselves, as a plug and play.
Oh, you are? That's the phrase you use.
Yep.
So some of the things you've had here then are quite big, you know, in terms of their physical size. They're quite big things. They're not like little floaty couple of corks floating on the tide, on the waves.
The technologies that we have tested at the grid-connected sites are generally full-scale prototypes. They're generally around 1 megawatt devices a lot of the time.
I've seen some of this stuff. I mean, that is monstrous.
So this is amazing. Aquamarine Power's Oyster. It's actually the first generation Oyster. They've taken a second generation now, one as well, which you can see operating here.
So that's what you'd see above. So there's quite a lot of that is then under the surface.
Yes, so most of it's actually attached to the seabed.
Right.
And this is like a giant flap.
And that just goes up and down with the waves?
Yes, it's a buoyant flap, so it's pushed forward with the force of the waves.
Right.
The buoyancy then brings it back up, and again it acts as a flap, so it actually pumps high pressured water on shore to turn up a turbine on shore.
Ah, right. So this unit here isn't generating electricity in this part of the machine. This is basically a massive pump.
Yes.
Right.
So it's an Open Hydro's turbine.
Right.
What you're seeing here is their test rig, which is built for the purposes of testing at EMEC. When it's deployed on a commercial basis, it will be deployed on a gravitational base on the seabed.
Right.
But this one allows them to raise and lower the device.
So this is only as they're testing it, so they can lift it up and down.
You can lift it up and down very easily, which means it's easy to maintain during testing periods, and also relatively easy to switch the devices in and out with new technologies, because they're actually on their 7th generation turbine. A company that were originally called Tidal Generation Limited, TGL, they were consequently bought over by Rolls-Royce, who was then consequently bought over by Alstom.
Right.
So they've had 2 different devices here. This is the 500 kilowatt device that we tested here, and then they took a 1 megawatt device.
Wow, that's huge.
As well.
It's a huge thing.
Yeah.
So that's effectively like a wind turbine, but that goes underwater. Effectively.
In essence, yes. So it's a 3-bladed horizontal axis turbine. Looks rather similar to the wind technology that you'll see, and you'll see that quite a lot of the technologies that have tested here for the tidal test site, there's a lot more convergence in terms of the kind of technology, or at least the look of the technologies that are required to take energy out of the tides.
That one is extraordinary. What's that
one?
This
is quite a different concept.
Yeah.
This is Flumil's device.
Wow.
It's a Norwegian company. They've got this helical corkscrew shaped device called the Archimedes screw.
Yeah.
So it's a rather different concept and quite nice looking.
Yeah, extraordinary. Looks like an amazing sculpture, doesn't it? Yeah. Right, and that's basically it's the tidal force that will turn that will turn generators and wow. So Stevie, I'm really interested to see this because I've heard about it before, but basically I've come out here to look at this amazing new facility, and what I'm looking at is 3 shipping containers on concrete blocks.
Very expensive shipping containers.
Are they very expensive ones?
Basically there's 3 units there, and the outer 2 units are basically a series of battery cells.
Right.
If you add up the cells together, each of these containers contain a megawatt of batteries.
Right.
Your centre container then is the inverter, the brains of the system, that then converts it back into connecting the battery to the Orkney grid or the national grid.
Right, that's quite big. So that's a megawatt in each one of those.
Megawatt capacity, but it's a half a megawatt hour of charge that's held in there. Yeah.
Half a megawatt hour, which then doesn't sound like very much.
Not at all when you see 3 huge 40-foot containers.
Yeah. So but the idea of that is that because Orkney is a unique place, isn't it? Because of the enormous amount of renewable energy being generated here.
Absolutely, the conditions in Orkney for renewable energy is fantastic.
Yeah.
People in Orkney have been very embracing on renewable energy, and we've actually produced more energy than Orkney can handle.
Right.
And actually more energy than the 2 cables it takes to the Scottish mainland can handle. And many times during a day even, we're exporting renewable energy across onto the national grid.
Right, but you're constrained by the size, the amount of electricity that can go along those cables.
Absolutely, right. and so in that instance we're actually having to switch off renewable energy because of the network capacity. So the battery was a trial it's in conjunction with Mitsubishi and
Right.
our generation part of the company. And they're basically, what they're trying to do is provide battery backup that when the grid is full, the batteries will absorb the energy rather than switch off
Right.
wind turbines.
Yeah, but then what is fascinating is it's a sort of microcosm of really the rest of the world here,
Absolutely.
isn't it? Because what we're standing next to is what was the power station for the island. Is that
Very
am I
much so.
correct? Yeah.
Yes, sir.
And that you know, that is diesel generators. The grid was from here out to everywhere in the island.
Very much so. When I started in the company, the only source for energy in Orkney was a diesel power station.
Right.
Hugely noisy, energy inefficient, pumping CO2 into the
Yes,
atmosphere.
yeah.
And now, and the hub of the electricity network was built from the station out.
Yeah.
Now in Orkney, there's some 700 points of generation between wind turbines and solar panels,
Yeah.
but they're at the spokes rather than the hub.
Yes. Yeah.
So the constraints are very often the conductors and the wires come back to the hub.
right. Well, how many people on the island? Roughly
22,000 people.
22,000.
Yeah.
And there's What did you say? 700.
700 generators.
700 generators.
Yes.
It is extraordinary.
Yes. The people are producing energy where it's needed,
Yeah.
rather than being transported miles
Yes,
and
that's
copper
true.
losses. So the farmer's producing on his farm, on his windmill,
Yeah.
the energy he's using,
Yeah.
and he's able to sell the product he doesn't to his neighbours. So yeah, it's good. Yeah.
But I mean, do you think are you doing things here, or can you start to understand how the grid needs to be changed and updated to accommodate that? Effectively, a reversal of the traditional.
I think as you said
generating
before,
method.
Orkney's a sizable, a scalable model
Yeah.
for the whole of UK, maybe
Yeah.
the whole of Europe.
Yeah.
When you look at the combination of wave, tidal, wind, even solar
Yeah.
in Orkney in the summer, and match that to UK, it is scalable.
Yes.
You can
Yeah.
understand the problem
Yeah.
in the whole country and in Europe.
So as you know, if you look at a map, Orkney is at the northern edge of the United Kingdom. Right at the top of the United Kingdom, that little island that lies off the coast of Europe, there's an even smaller island called Orkney just off the top. And this island is just amazing to see. In some ways, it's very symbolic, because this island produces more electricity than it can use purely from renewables, from wind and solar, mainly wind, and some tidal. It's just extraordinary what's going on here. It's a real test bed for the whole country. And what it feels like when you're here is that what they've done here is gradually leaching its way down through the rest of the country, because Scotland produces an enormous amount of energy, generally from renewables, and the United Kingdom is slowly catching up. And it feels like this is where it started. This is where they've proven that it's possible to have 100%, not like 50% or 60% or 40%, 100% renewable energy for really the vast majority of the time. They export electricity because they make too much. They don't know what to do with it. They're talking about how to use their excess power. It's uncanny. They're going to heat greenhouses. You know, it's amazing what they're doing with it. And of course, there's lots of electric cars here because it makes an enormous amount of sense, because they're much cheaper to run, and they're not powered by coal. They're powered by the little breeze I can feel now that's turning that massive wind turbine that I'm looking at as I stand here. Everywhere you look on Orkney, there's wind turbines, and they're beautiful. It's absolutely amazing. If you ever get the chance to come up to Orkney, grab it.